All right, so we're going to go over 4.2, number 5, and it's asking us to find the domain of the rational function. Okay. You haven't, we've done a little bit of this, but we haven't figured a lot of this out, okay? So I'm just going to graph this, and then hopefully you'll see a pattern that'll help you understand what I want you to see. So here's my Desmos. I'm going to graph number 5. It's going to look kind of funny, but so it goes 1 divided by, and then I got all these parentheses, right? X plus 4, oops, that's Z plus 4, my bad. X plus 4, close open, X minus 2, close open, X minus 7. Oh, wow, look at this thing. What? All right, so they're asking me to find the domain. Okay, before we walk into domain, let's define what domain is. Okay, when I tell you to look for the domain, I'm telling you domain. Look at the graph from left to right and find all of the good x's, or look for places where the x can't be plugged in. Hint, hint, right? We talked about that earlier today. So let's make this a little bit more here. Here, switch my. Okay, let's highlight that so you guys all see that. So look from left to right and look for all of the good x's, or look for places where x can't be plugged in, right? So here goes. So this is what my function looks like, and it looks kind of funny. So let's go home. Oh, look at that. It looks like this, this, and this. What do you guys notice? Looks like a bunch of what? Kind of. So let's look at regular 1 over x. Okay, turn this guy off. Do you guys all see it? What are the most important parts about this function here? What were we talking about earlier? It's reflected. What else? The asymptotes. Yes. So pay attention to the asymptotes to my green friend. Do you see asymptotes? Yeah, you see a lot of asymptotes, right? Hey, what are your asymptotes for this one? I'm not talking about horizontal. I'm talking about vertical, right? I'm looking from left to right. I'm looking at my domain. What x's can't I use? What x's can't I plug in? Ooh, -4? Oh, okay, -4. Anything else? 2 and 7. Oh, I see why you're saying that. Because look, it goes all like whoop, and it goes whoop, 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 right? It goes all like in opposite directions at those numbers, right? Okay, now if you tell me that I have asymptotes at x is equal to -4, 2, and 7, what I really want to do is find out why that's important for this function. So now I want you to pretend that I didn't just graph this, and I'm only showing you this equation, right? Here or here, right? And I say, hey, what can't x be? Do you see why these asymptotes show up? Why do these asymptotes show up based on this equation? Yeah, because of the denominator. Exactly. That denominator tells you some stuff, right? Like, let's just take -4, for example. Why would you say x is equal to -4 is an asymptote based on this equation? What do you see? What do you see? Yeah, this guy. Hey, Miss Johnson. Okay, so let's plug it in. Let's plug in -4 and see what happens. -4 plus 4 is 0. Oh, and then if I multiply it by something, I don't care what it is, and I multiply it something else, I don't care what it is. Because 0 times anything is always going to give me 0. Can I take 1 and divide it by 0? No, this is the discussion for the past couple days, right? No, don't do it. It's that confusing concept, right? It's undefined. So let's back it up. Oops. Let's pretend that I give you this. And I said, hey, what can't X be? What is one of the numbers that you would tell me? X can't be what? -4. Good. Why not? Because that would make my denominator 0. Good. Is there another number that X can't be? Yeah, X can't be 2. Is there another number that X can't be? 7. Okay. And if you're wondering where did that person get them, they're just almost like we did up here, right? In the problems that we did earlier, we set each of these equal to 0, right? So your domain is going to look like this. This is the easier way to write it. It's all real numbers. That's what the fancy R is, except for X can't be -4, X can't be 2, and X can't be 7. Okay. Everybody okay with that? Okay. If you notice, number 3 matches number 7. Do you guys all see how number 3 matches number 7? Let's do number 7 at the same time. What can't X be in this case? Yeah, X can't be, and then you would just say all of these, right? X can't be -1/3. X can't be 3. X can't be -3. Got it? So wait, if you were going to explain this to someone else, what would you say? How do you find the domain of a rational function just looking at the actual function, not looking at the graph? What would you tell them to look at? Yeah, look at the denominator and then do what with it? What should I do with my denominator? Set it equal to what? Yeah. So you're saying to find the domain of the rational functions, you just want me to set the denominator equal to 0 and find out when X can't be those numbers? Exactly. Why not? Why can't the denominator be equal to 0? Exactly. The denominator can't be equal to 0 because when you take 1 or number and divide it by 0, you get the number undefined, which is not a number. I shouldn't say it like that. You get a concept called undefined. It doesn't work. Your calculator says error, right? So that's how you find the domain. When you're looking at the picture, the graph, you look from left to right and you find all the places where X can't be. See, X can't be -4, X can't be 2, X can't be 7. Good? Good job.